Number 20, again, I'm dealing with a graph that's not shifted, so that is amplitude is 2 units above and 2 units below. So I could label that R equal 2 and R equal a -2. This is a graph of a sine wave, starts at the origin. And again, one period will do. I could sketch the whole graph based on this traditional graph. This is 2 pi over 5. This is half of it, pi over 5. This is pi over 10. So I need to cut this. This is pi, 10 pi over 10, which means 5. I need to cut each quadrant into 5 equal parts. Doesn't have to be perfect. 1, 2, 3, 4, 5 will be the pi over 2, 6, 7, 8. Once you get used to this, you really don't have to do all of this. 9 and 10. And if I start with, let's say, if I start at 0, I am at 0. Increases. By the time I hit 1 pi over 10, there's 1 pi over 10. This maxes out at 2, right there. And I know from symmetry, if it took it pi over 10 to get the upper half, pi over 10 to get the other half. This is, if it's odd, this is a 5-leaved graph, which means they are 2 pi over 5 apart. Since that's over 10, to make that over 10, multiply by 2. So 4 pi over 10 apart. This is 1 pi over 10, 2 pi over 10, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20 pi over 10. Since this maxes out at pi over 10, and I know the next one is going to be 4 pi over 10 away from that, 1, 2, 3, 4, that's the next one. 1, 2, 3, 4, the one after that, 1, 2, 3, 4, and 1, 2, 3, 4. And this is probably the most efficient way of graphing those, using symmetry. And the graph looks something like this. And now what I want, I would like to find all of these areas. No need to find all of them. They're symmetric. So all what I have to do is find one of them. And there are many ways I could do that. I could say this area is going to be the integral. I could run from 0 to 2 pi over 10 if I want, of 1/2 twice the sine of 5 theta squared d theta. And I could say that's 1, 2, 3, 4, 5 of them. There it is. On the following, I have find the area, the region that lies inside of the first. Let's see what that is. I have a vertical shift of r equal 1. I move 1 unit above and 1 unit below. That makes it r equal from 1, r equal 2, and r equal 0 as sine wave starts at the origin. We did this graph already, but it's good to practice this over and over. 2 pi, pi, pi over 2, and 3 pi over 2. So I know this graph, at 0 I am at 1. Decreases. By the time I hit pi over 2, there's pi over 2, I am at 0. Increases. By the time I hit pi, I am back at 1. Keeps on increasing. By the time I hit 3 pi over 2, I am at 2. There's 3 pi over 2, and there's 2. Oops, I want to look a bit nicer. There we go. And symmetry, right? Come on. Right there. Now, when I get to the second graph, I notice that this says r equal 1. Well, that's a circle wrapped at, it's not centered properly. Here it is. So what this says, find me the area that is inside of the purple and outside of the green. So the common is right there. Now I need to know, I need to make sure where this touches. The way it works, To find the intersection, I take 1 minus the sine of theta and set it equal to 1. And that is when negative the sine of theta equals 0. Well, I know where the sine of theta equals 0. That is at 0, so I know that's a point of intersection, and at pi. So good. If I am to start from, I could say area equal the integral. If I am to start from pi and 1 to 3 pi over 2 of 1/2, and if I draw my arrow, do you notice the tip of the arrow is always the same? The tip of the arrow is always the purple in this case, 1 minus the sine of theta squared, minus the base of the arrow is the green, and the green is 1 squared d theta. That's half of it, so if I multiply it by 2, there it is. Of course, I could have did from pi to 2 pi. That will work as well, but I want you to make use of symmetry whenever you can. You don't have to, of course, but it helps a lot. And here I have two graphs. The first graph, r equal 1 plus, oh, this is not centered properly. There we go. R equal 1 plus the cosine of theta. So if I go up 1 unit to r equal 1, oh, this is going to be a bit harder. Okay. And I move a unit above it and a unit below it. I would be a unit above, that's r equal 2, a unit below, that's r equal 0. Cosine starts at the amplitude, runs down to the amplitude, back to the starting point. And there is my graph, 2 pi over 2. So at 0, I am at 2. Decreases. By the time I hit pi over 2, there's pi over 2. R will equal a 1. Keeps on decreasing. By the time I hit pi, r equals 0. And by symmetry, I could finish this graph with ease. And when I look at the second graph, I'm looking at r equal 2. That's the vertical shift. I move a unit above and a unit below, a unit above and a unit below. So if I am at r equal 2, a unit above is r equal 3, a unit below is r equal 1. A cosine wave, this is upside down, so it starts on the amplitude, but the bottom amplitude, and there's the graph. And this is 2 pi over 2, and 3 pi over 2. At 0, I am at 1. At 0, I am at 1. This increases. By the time I hit pi over 2, I am at 2. 1, 2. It keeps on increasing. By the time I hit pi, I am at 3. There's pi, there's 1, 2, 3. It's cluttered by all of these other angles. I'll take them off in a minute. And from symmetry, I know how this is going to work. And that's how the graph looks like. So one of those look like this. Oh, come on. One of those, there we go. The colors are kind of cluttered. I'll clear that up a bit in a minute. Now, the most important aspect of this graph is figuring out where those are equal. Where does 1 plus the cosine of theta equal 2 minus the cosine of theta? That is when 2 the cosine of theta equal 1, or cosine of theta equal 1/2. I have a reference angle of pi divided by 3, and I know cosine is positive in quadrant 1 and 4. So in quadrant 1 it is pi over 3 and 5 pi over 3. So I could eliminate the 30 and the 45 out of the equation. I really don't need that. And keep the pi over 3's. So I know that my graph, my line is way off. I know that they cross right there at pi over 3, and they cross right there at 5 pi over 3. And there it is. That's really important. Now, if I go in and fill in what they want me to find, they said find the area, I'm sorry, right there, inside of the first, outside of the second, inside of the red, outside of the green. They're talking about this area. That's the only area that I want. So if I am to say, let's say area is the integral. If I run from 0 to pi over 3, right, of 1/2, and let's see what's the outside. The tip of the arrow is the red. The red is, I did it right. That was the green. The red would be 1 plus the cosine of theta squared minus the green, and I know that the green is 2 minus the cosine of theta squared. And since that's half of it, multiply it by 2. If I want to do the whole thing, I wouldn't say 5 pi over 3, I'll say negative pi over 3. I suggest you use symmetry, that helps a lot. I want to do this example. I'd like to find the area this encloses. No matter what I ask about anything like this graph, you need to know where the inner loop begins. And let me elaborate. R equal 1 is a vertical shift. I go 2 units above, that's R equal 3. And 2 units below, that's R equal -1. A graph of a sine starts at the origin, runs up to the amplitude, back down, and back to the starting point. That's a full cycle. This is 2 pi, this is pi, this is pi over 2, and this is 3 pi over 2. So I notice this graph starts at 0, I am already at 1, 0, I am at 1, increases. By the time I hit pi over 2, R equal 3. There's pi over 2, and there's 1, 2, 3. So increases. And then decreases back. By the time I hit pi, I am at 1. There's pi, and there's 1. So those uppers I really didn't use or need. Now, I do notice something happens. Before I reach 3 pi over 2, this hits 0. I need to know where does that equal 0. That's 1. The sine of theta equal, subtract 1 from both sides and divide by 2. So I have a reference angle of pi over 6. And where's sine negative? Sine is negative in quadrant 3 or 4 at 7 pi over 6 and 11 pi over 6. So the only angles that I need are the over 6's. I'll get rid of everything else. Now, I know that this right here is 7 pi over 6. So by the time I reach 7 pi over 6, this zeroes out. The graph, this is a bit off. I just want it to be a bit more tilted so I can get a better graph. 30 degrees step up right there. So this zeroes out. By the time I reach that, oh, how am I going to reach that now? Okay, well, we get the idea. This zeroes out right there. Now, I notice between 7 pi over 6 and 3 pi over 2, R is negative. If R is negative, I'm no longer in this quadrant, I am in this quadrant. It traces there, and by the time I reach 3 pi over 2, R equal -1. There's 3 pi over 2, and there's -1. And it comes back, and we know that this is symmetric. Now, no matter what I ask, you need to know that this inner loop starts at 7 pi over 6, terminates at 11 pi over 6. If I want to find the area, that's going to be the integral. And let's see, look what happens. If I run from 0, do you notice that that's including that loop? So if I run from negative pi over 6 all the way up to pi over 2 of 1/2, 1 plus twice the sine of theta squared d theta, and double that, that'll do the trick. I could have also started from pi over 2 all the way to 7 pi over 6 and doubled that. There's the homework for that section.